Hello and welcome again to this YouTube channel. So today we are looking at finding the extremum point. Okay, similar to the previous video, but right now how can we find this by using our second derivative test? Okay, so earlier we have first derivative test and then now we are focusing on second derivative test. All right, so I show you two example, different kind of example in a way. Okay, so the first one straightforward. Okay, so we start with this first one first. Okay, so as usual, we need to find, we need to find our first differentiation for our x similar. Okay, just do the similar process. You have 32 minus 4x cubed. All right, and then you put this equal to 0 and then you solve, and then by the end of the day you know that your x equals to 2. I hope you get it already. Now we need to find the valuation, right? So our point is actually f2. You put into your equation, so actually your point that you need to consider is 248. Okay, we put that into our advisement. All right, so this is our points. And then we want to know whether our critical point is it a maximum, minimum, or what. All right. So this is when you do the second derivative test. You get your first derivative test, and then from your first derivative, you derive it again. Okay. And then once you derive this, meaning that you derive from your f prime. Okay. You only have negative 12 x squared. Okay, the difference between this and also f prime, all right, if you want to find the critical value, you just equal your f prime into 0, okay, equal to 0, right? But in this case, for f double prime, the second derivative test, you do similarly as how you test for your first derivative test, okay? Earlier, in the earlier video, when you have first derivative test, you put your critical value inside your f prime. Okay, so similarly, once you have f double prime, you put your critical value, which is 2, okay, your x, and then you put it, okay, you put inside your double prime, and then this is the value that you have. Okay, so you calculate this and then you get negative 48. Okay, whatever happened for the second derivative test? Okay, if you have negative 48, you know this more, you know negative 48 is less than 0. And then once you get this, you can safely say that your point is a maximum. Okay, if you get positive, your point is a minimum. Okay, it is a shortcut. All right, it is a shortcut. So basically, you can say that, oh, actually, my point 248 is actually a relative. Why you say relative? Because you don't know the original graph. Okay, for this particular function, maybe it has a very uh, many different types. Okay, so you safely you can say it is a relative, meaning that nearing its neighborhood, this is the most maximum point. It's like that, so it is safe for you. Doesn't matter if, let's say, you have another different point put together in different points put all together. Okay, so this one is clear. All right, whatever happened if we have this problem? Okay, why this is interesting? Okay, look at this one. The same thing happens. You need to find your f prime, and then your f prime now just becomes 3x minus 1 square. Okay, that's it. And then you know you can equal this with 0. And then la la la, you get x equal to 1. Okay, fine. Once you get f equal to 1, now you see, before that, okay, I want to jump into conclusion. Okay, but anyway, if you want to find the exactly points or the values, so you put it back and then you get 0. So this is the critical point that we have. All right, okay, that one is clear. Okay, now how can we do, let's say we proceed to f double prime over here. Okay, from here, from here, your f double prime is actually 6 x minus 1. All right. And then as earlier, we have f double prime, and then we put our critical point number 1 inside these particular values. You can see over here, my value now becomes 0. We know previously, if I have negative value, meaning that I have a maximum points. If I have negative, if I have positive value, then my point would be minimum point. Okay, but now 0 is what? It is not a minimum point. It is not a maximum point. So how to say something about this? Okay, this is what happen if, let's say, you have a situation where your f double prime give you 0 value. You cannot safely say, or you cannot safely make a conjuncture. Okay, whatever happened that you have. Okay, well, you cannot say it is a maximum. You cannot say it is a minimum. So you need to go back to your first derivative test. Okay, so that is the minus side of f double prime. Okay, that is the minus side of it. But more or less, it's not that often you are deal with this kind of problems. All right, so normally you can just simply use f double prime altogether. Okay, but if you want to find the first derivative test, okay, and then again you need to do the similar ways. Okay, you know that your critical point, this one is not bad. You only have one as your critical point. Okay, and then you find the neighboring values there. Okay, so I just pick 0.5. Okay, just to simplify things. Oh, sorry. And I also take 1.5. All right. And then once you put this into your f prime, okay, your f prime, all right, not f double prime, you can see your f prime, the first point you have positive, and then f prime, the second point for 1.5, also positive, meaning that your value is like this and also like this. What does this tells you? Okay, this tells me that during the time, okay, if let's say this is my graph, okay, you have something similar like this. Oh, sorry. Okay, the derivative meaning that the slope, right? Okay, if I find the slope over here, and if I find the slope over here, the slope is still the same, meaning that your slope is like this, positive. But at one particular point over here, it does not change. It is your critical point. Your f prime now becomes 0. Okay, so it's quite interesting things to look at this one. All right, so you go out from here, and then it slightly does not change at all, and then it goes back to the other side. So this is what we call an inflection points. Similarly, if let's say you have something like this, and then this is your critical point, so this one negative and also negative from your left and also right side, you can also call this an inflection point. All right, so now you can safely say that 1 0 is an inflection point. All right. Okay, so I hope you enjoyed the lesson. Again, I know this is a little bit confusing. If let's say this is the first time you listen to uh, uh, the application part of the application part of derivative. So it is better if you listen to this carefully again and again until you understand what is going on here. All right. So I'll see you guys in the next lesson. All the best.